So let's convert this into percentage, and I'll choose as denominator as 71. Okay, so I'll just click over on the and right click, get the show field list, and here if you look at the I option is there, right? I click on this I option, then I'll go to show data as, and here I'll choose percentage of the grand total. The various option is there, percentage of, percentage difference from, percentage. The various options are there. Okay, so I'll just first will do the percentage of grand total and click OK. So if you see now, I can understand. 14% is on time, 30% is late, and 50 to 54, 55% is no outcome. Here I can understand now from this percentage. The purpose of doing this percentage conversion is to know the scale, whether the scale is high or low, which outcome has the biggest scale and which outcome has the smallest scale. Is it clear why we are converting it count into a percentage?
To know which has a higher percentage or weightage. The late percent here is 31, which is greater than on-time percentage. So the late packages are higher.
Right. And even if you look at the no
Anna, you are not audible, Anna. Hello.
Okay. Hello.
Now it's audible, Anna.
Okay.
Thank
So we are trying to understand which one has the highest ratio or highest fraction. So no outcome is 55%. Means we have to do the research to understand why we have the 55% no outcome. Is it because the delivery happened and the entry is not done into the system? Which is that the delivery has already happened, but the entry is not happening into the system, or delivery has not happened.
Anna, what I have done is in the rows column, I have taken the customer, and in the columns, I have taken days of delay, Anna, so that all the customers are on the rows, and in the columns, I have taken this days of delay earlier.
That's fantastic. That is fantastic. Because we are trying to understand the late and on-time percentage by customer. So suppose if I take the customer into the row now. So I'll take this data delay into the columns and put the customer into the rows, right? This is what we have done.
Yeah, exactly, Anna.
Okay. So now what I will do is, I just before that I'll go to second stage. Let me put this here. Okay. Now I'll go back to I. Again I'll go to show data as. And now here I'll choose, instead of percentage of grand total, I'll choose percentage of. Okay. I'm choosing percentage of. So I'm going, after choosing percentage of, I'm going to same variable. Days of delay. I've selected this. Okay. Now here I will choose percentage of late. So what is the meaning of percentage of late? Now late count is a denominator. Previously the grand total was a denominator. Now my late count is a denominator. See, now the value is changed. So once again I go back to here, I'll go show data as, I'll choose percentage of. Now instead of choosing late, I'll choose percentage of on time. So the denominator in this case is the on-time count. On-time count divided by on-time count. Late count divided by on-time count. No outcome divided by on-time count. If I want to choose percentage of row total, I'll choose percentage row total. Want to choose percentage of column total. Show data as I go to percentage of column total. Right? This is how you need to carefully select your denominator when you're trying to find the percentages. It is very important to have that idea. Now what I'll do is I'll put the customer. I'll take the asset delay into the columns. I'll put the customer into the. Now we have three options. One is calculate the percentage of column total, percentage on base of row total, and percentage on base of grand total. We can find the on time here, on time or late percentage by customer, by customer. But we have three options here. First option by row total. By row means by customer wise. Second, column total. Sorry, first is by outcome wise. Each customer. Second is by customer wise for each outcome. So there is a difference in the sentence. On time late and by customer. So here we can do by. Let me remove by customer. On time and late percentages. So the first is by customer wise, by outcome wise for each customer. Second is by customer wise for each outcome. So what is difference?
By customer wise for each customer.
So for the first one, we are comparing with other customers, and for the second one, we are comparing one customer with late or on time. The outcome.
Okay, how will do the calculation? What is the formula?
On time percentage. So 100% yes.
In the first case, what is the formula?
By outcome wise for each customer.
For 2 by 4, 2 by 4. Late by grand total.
Okay.
Late of, for example, if you are taking Agila,
Okay.
okay, late percentage by grand total, and on time by grand total. As on time is nothing here, so 50-50.
So it is grand total of all the
Agila.
customers only for Agila.
So for the first one, outcome wise for each customer, we need to take the grand total of all the customers. Because we are comparing Agila with all the other customers. In total, 71.
But I have written by outcome wise for each customer. But I have not mentioned here outcome wise for total customer. I have mentioned here by outcome wise for each customer.
Outcome
I
wise.
didn't mention the outcome wise for total customer.
Then outcome by only total outcome of particular customer.
Okay. So here we'll use the formula, the first one, the outcome count. Okay, the outcome count divided by total orders. Total orders for the customer. Total orders count for the customer. For the customer. For the customer. It makes sense?
Outcome by outcome wise for each customer. It's a late percentage by outcome wise for each customer. Late percentage. So the late to divided by outcome wise for each customer. So late का लेगा delay 4 to outcome
Okay, so look at here. This is our Azila. Right? This is one customer. It has 3 outcomes. Outcome 1, no outcome. Outcome 2, late outcome. Outcome 3, on time outcome. Right? We have 3 outcomes. And total outcomes is equal to total orders. Am I right?
outcome plus no outcome, late outcome, on time. So this is also the days of delay, Krish. One outcome. No.
See how many are. See, days of delay is all about calculating the days of delay. Days of delay.
So,
Days of delay. Right?
hmm.
How many days of delays are there for each order? Take this. One will be no delay. One will be no data. And one is delay. So no delay is on time. No data is no outcome. And delay is late outcome. So days of delay has 3 outcomes. This is what actually this data is showing. So how many are this 2 is a count of no outcome. This 2 is the count of late outcome. How many orders are late? How many orders have no data? How many orders are on time? If there is no data here, it is called 0. There is no orders which are on time. 0 outcome, 0 on time outcome, 0 on time outcomes. So 0 outcome on time.
How many days of delay? No delay, no data, and delay on time, no outcome, and it could be late. Days of delay. Hmm.
Okay. So here, this grand total, this 4 represent total number of orders for Azila. This is all customer-wise total number of orders. These are all the customer-wise total number of orders. What is this? This is no outcome. This is late outcome. This is on-time outcome. And this is total orders. Which is equal to 2 plus 2 plus 0, 4. 6 plus, this is 6 plus, let me write down this here. This is 3 plus 2. This is 1 plus 2. Right, these are total number of orders. So now if I want to find this, so in this first case, 0 divided by 4. Second case, 2 divided by 4. And third is 0 divided by 4. First case, second case, this is as enough. Now we are trying to find up. Suppose we find this now. Lux power. What is Lux power? First case, 1 divided by 3. Second case, 2 divided by 3. And third is 0 divided by 3. Because now our denominator is the total orders received by each customer. Total order received by each customer.
Chilla. 0 divided by 3.
This is outcome divided by total order by customer. So what is the outcome here for the first case? Days of delay, no outcome, 2. 2 divided by total orders received by the customer. Late, 2 divided by total order received by the customer, that is 4. 2 divided by 4. So same thing if I apply in the Excel. So there are two ways I will just show one way, the manual way. For that I will just select here, copy. Okay, I'll just paste at the bottom, not bottom. We'll choose a different sheet because we'll use the same sheet for other computations. Paste special values, and this is a report which you have created.
So,
now let's see. This is by order by. Let me also write here no outcome. So report is ready, and now we will work on this report. So we are finding what's our objective? 1, 2, 3, and 4. 3, 1, 2, 3. 1, 2, 3. We'll merge this, and this is outcome by total order or total order by customer. So here it is 2 divided by 4. Try this. Somebody should be. So the 50% order have no outcome. Similarly, if you see here, once again I put the formula 6 divided by this 6. So I'll drag this and I get this one. Now, see, third one, if you look at this, this is this divided by this. I'll freeze this. Right. Let's convert this. So, in the case of Agila, the 50% orders are late, 0% are on time, 50% are no outcome, no data. In the case of Apple Swami, APL, sorry. In the case of APL, we have total orders have no data. It means they could have been dispatched, but the data entry has not been done, or no dispatch has been done. So we have to do the research on that to confirm. Third case of Upper Swami, we have 0% known outcome, and whatever orders we have received from Upper Swami, everything has been late. The fourth case, this divided by this. Fifth case, this divided by this. So if you want to do like this manually, it is a very headache. What I'm going to do is, I'm going to use pivot table. In this pivot table, I'm going to convert this. How I will convert this? Click over here. Okay. Then you get your field list. Click on the I. Then click on show data as. Then click percentage of row total. Percentage of row total. So this is what we got. I'll just convert this into single. Okay, the first one is 50%, 50%. This is what we got here. 50%, 50%. Third one, second one is 100%, 0%. 100%, 0%. Third one is 0, 100, 0. 0, 100, 0. Four, let's the fifth case, 50, 50, 100. 50, 50, 100. 50, 0, 50, 50. 0, 50, 50. Instead of doing manually, we can do. Now we can copy this report and paste here. Paste special values. Now the report is ready. Convert this into percentage.
Shows data.
This is outcome by outcome wise for each customer, right? By outcome wise for each customer. Now, second question, by customer wise for each outcome. What will be the formula? The objective is by customer, but for each outcome.
Percentage of total column. Percentage of
What is the formula? I just change it back to the count because we need to count information. Store data as. Click on this and no calculation. Okay, so this is our count. You want to go back to count, you can go back to count also, like this. So what is the formula of the second one?
By customer wise for each outcome. customer-wise each outcome. So Agila is one customer and each outcome. So here outcome is the late and on time both, correct?
Yeah.
So by customer wise for each outcome, तो late के लिए जैसे यहाँ पे तो नहीं है one time the days of delay.
Outcome count by total customer count for that outcome.
Yeah, each
Outcome
no.
count by total outcome for the customer. Movavi,
Outcome count by total
Count of
customer count.
yeah,
Total customer
each customer
total customer
total
count.
count, total customer count.
Total customer count for that outcome.
Let's see to follow this method formula and complete it. So let's say outcome count is how much here? For example, 2. Late outcome, right? Late count is 2.
2
And
by
total late count. Total
22.
late count. Total late count
22.
22. So this is late count for Agila. So late count. So this is outcome count for the customer. Outcome count for a specific customer. So here is saying this late count is a outcome count for Agila only, right?
Yes, only for Agila.
Only for Agila. Divided by total late counts for all the customers. That's 22. That is 2 by 22.
total late count.
Total late count. Late
The
outcome.
grand total.
Each outcome.
Including all the customers. Including all the customers. We're trying to understand the late count of Agila with respect to the total late outcome for all the customers.
All customers.
So out of 22 lates, 9% is late of Agila. Total late outcomes are 22. Out of 22, 9% is from the Agila. The contribution is from Agila is 9%. Is it clear?
Yes.
Shoaib got it. Priyanka, is it clear?
Yes.
जो total count है उसमें से 9% जो लेट आ रहे हैं वो Agila से आ रहे हैं.
Correct.
इसको अगर मैं convert, if I want to convert the same thing in pivot table, I'll click here, go to show field list, and then go to I of the value section. Total data is percentage of column total. Click OK, and I just convert this into single digit. See now, but this is what we got here, right? 9%. Out of total on time, 20% is from Hospira. 20% is from Shanta Biotech. How this helps us? This helps us in doing the prioritization. This helps in our prioritization, which customer we should focus?
Anna,
Customer.
small doubt, Anna. Here, as our data is like limited, like almost 28 customers. So what if like if the data is huge? So you asked us to find which product has the most on time percent or the most late percent. So assume like if there are some 1500 uh, rows.
1,500 crore products.
No, no, not crores. 1500 rows.
Hmm.
1500 customers. Like the data is huge. Here, by just looking, we can say okay, 20% on time is the highest, and 32% for Ceylon. Late percent is the highest one, or of all the customers.
Yeah. So what you do, you have to apply the Pareto. You have to apply the Pareto principle, ABC principle. So most of the lates are coming from the 20% of the customers or 80% of the customers. Which customer you need to focus first? So who are the top? Who are the top performing customers, and who are the top non-performing customers? You have to divide them, and that is what Pareto principle does. This is called 80-20 rule. We'll see that. So that is what we have to apply the Pareto principle. That is called 80-20 rule or ABC rule. All three are same. Pareto principle, 80-20, ABC rule. So you have to do the prioritization. Who are the top performing customers and who are the top non-performing customers? Who are the average customers? So your focus will be where? The top non-performing customers and the average customers. So in this case, if you look at, let's copy this data. This data is ready now. So if you want to know who are the top performing customers, so I'll just go and put a filter here. And I'll say descending order. Now look at here, we'll ignore this grand total. So if you look at the top performing customers are Hospira, Shanta Biotech, and the top non-performing customers are Wintech, Unique Biotech, Ultra Labs. Same thing if you want to see top non-performing customers, you go ascending order. So non-performing customers are ascending order. Let's put ascending order. So if you look at whoever is having the least on time, they're on the top. And whoever is having the highest on time, they're at the bottom. If you want to say by late, who is the top non-performing customers? Descending order. Ceylon has 32% late. Upper sum is 14%. So whoever is the top non-performing customers, we can also see by the attribute using late percentage. The bottom are the best from the late point of view, and top are the worst from the late point of view. Want to go to on time is opposite. So whoever is a top, whoever is doing the best, they will be on the top. In the case of descending order, means highest to lowest. And whoever is the worst performers, they will be at the bottom because their on time is 0%. So you want to take the customer or customer performance, you can use on time parameter or you can use late parameter. So what you would choose, on time or late? If you choose late, means whoever are doing more late orders, they are not doing well. Whoever is